Question number 24 says, if sine of 2x plus 7 equals cosine of 4x minus 7, what is the value of x? Well, I know that if we have sine of an angle equals the cosine of an angle, then the sum of these two angles are 90 degrees. It's because they're complementary. So what is that going to look like? If they're complementary, then they add to 90 degrees. So we know that 2x plus 7 plus 4x minus 7 equals 90 degrees. We can simply combine like terms, and so we've got 6x, 7 minus 7 is 0, 6x equals 90. We're going to divide both sides by 6, and when we do, x equals, of course, 15. Is that an option? It is option number 2. Question number 21. For the acute angles in a right triangle, sine of 4x equals the cosine of 3x plus 13. What is the number of degrees in the measure of the smaller angle? And that is our objective. All right, so let's diagram this right triangle. And I know that if this is a right triangle, of course, that this angle is 90 degrees. And this is 4x. And we'll label this angle 3x plus 13. Beautiful. And so what do we know? We know that if this is 90 degrees, of course, and the sum of the three angles equals 180, then this angle plus this angle equals 90. These two angles, of course, are cofunctions. They're complementary. And so let's set them equal to 90 degrees right now. So it's going to be 4x plus 3x plus 13 equals 90 degrees. Beautiful. And so we can combine like terms, and we know that 4x plus 3x is 7x. And I know that if we subtract 13 from both sides, 7x equals 77. And x is then going to be equal to 11. Amazing. All right. We are not done yet. And you know what, ladies and gentlemen, do not be fooled, because I see that 11 is an option, but that's not the degrees in the measure of the smaller angle, so we can eliminate this right now. So what we need to do is we need to plug in x into both of these acute angles. And so if we're going to do that right now, I know that 4 times 11 gives us what? Let's pop in. It's going to give us, of course, 44. All right, so this angle right here is 44 degrees. Now, is this the smaller angle? We don't know yet. Let's pop in 11 to the other expression. All right. So 3 times 11 is 33 plus 13 equals 46. All right, so this angle is 46 degrees. Which is the smaller angle? 44 degrees, of course, is a smaller angle, meaning that option 3 is the correct answer. Question number 16. It says, in circle Mbelow, diameters AC, chords AB and BC, and radius MB are drawn. Which statement is not true? So this, of course, means that 3 will be true, and we've got one false statement. That's what we're looking for. Let's start with option 1, and it says triangle ABC is a right triangle. Well, it kind of looks like one if we're just eyeballing it, but that's not enough. What I do know is that we've got a inscribed angle right here from ABC, and I also know that it intercepts its diameter, right? And so I know that a inscribed angle is 1/2 its arc, and I know that this, of course, because it's the diameter, this is 180 degrees, so I know that this has got to be, ABC has got to be 90 degrees, and this is a right angle, so this is true. ABC is a right angle, so option 1 does not work. What about option number 2? So it says ABM is isosceles. Let's take a look at this a little bit further. I notice a few things. An isosceles triangle has to have 2 sides that are congruent. And I know that AM and BM are congruent because they're both the radius, right? So what does that mean? That it is isosceles. We can eliminate option 2 as a possibility because that is true. Option 3, arc BC, which we have right here, is equal to angle BMC. Is this true? Is this the case? It is, because we know, of course, this is a central angle, right? M is the center, and central angles are equal to the arc, so we know that we can eliminate option 3, and that means that by process of elimination, option 4 has got to be the answer. Let's take a look at it a little bit further just so we can verify it. So we've got arc AB is equal to half of angle ACB. And I remember that ACB is the inscribed angle of arc AB. But what I also know is that this arc is twice as much as the inscribed angle. So if this is 80 degrees, then ACB has got to be 40 degrees. But that's not what this is saying. This is saying the opposite of this. It's saying that this arc is equal to half of ACB. For this to be true, we would need to double 40 so that 80 equals 80. And this would have to be, instead of 1/2, 2. Correct answer is option number. Question number 4. It says in the diagram below, the measure of arc ABC equals 268 degrees, and it says, what is the number of degrees and the measure of angle ABC? So that's our objective. We need to determine the measure of angle ABC, which we know is located right here. So before I do anything else, I'm going to go ahead and label this diagram. I can see that it says that the measure of arc 200 of ABC is 268 degrees. Okay. And so what does that mean? That means that arc AC, which we can see right here, is how many degrees? Well, I know that a full circle is 360 degrees, and so if we subtract 268 from 360, that's going to give us 92 degrees. All right, so we know that this is 92 degrees. We know that this is 268. How do we determine the measure of angle ABC? Well, we know that this is an inscribed angle, and we know that for an inscribed angle, the measure of the angle is 1/2 the arc that it intercepts. So that if this is 92 degrees, I recognize that 92 divided by 2 is going to give us what? 46. So clearly, angle ABC is going to be 46 degrees. That is option number 4.